Today we're joined by Dr. Ken Overturf, a USDA-ARS research scientist and salmonid fish breeder at the Small Grains and Potato Germplasm Research Unit located in Aberdeen, Idaho, and Dr. Josue Chinchilla-Vargas, the animal breeding coordinator at Breeding Insight. Breeding Insight is a USDA-funded initiative hosted at Cornell University, whose mission is to integrate tools, technologies, methods, and insights into USDA-ARS specialty crop and livestock breeding programs. These technologies can cover various needs, including genomics, phenomics, data management, data analytics, and breeding support. Each USDA breeder sets the needs and objectives for BI support so BI can provide a customized support plan of action. My first question is for you, Ken. Can you tell us a little bit about your breeding program and share some specific logistical challenges you've faced?
Okay, my breeding program started about in 2000, and I was tasked with the to select fish to utilize plant-based diets more efficiently. All right, specifically salmonids. So these are piscivorous fish or carnivorous fish, and not in the wild. Don't forage on plants and don't utilize that so much. So there were, a number of different ideas from different people on what specifically was going to be done. I mean, some people thought protein's protein, so it doesn't matter if it's plant or animals, and they'd be fine. Some people thought, you're trying to make an herbivore out of carnivore. It's not going to work. They're not going to utilize it that well. And, we, in a way, we found a little bit of both. What at the same time, well, not at the same time, but shortly afterwards, I started other selection programs started elsewhere in Canada, Norway, Chile, etc., where they had France, but they were en route trying to do the same sort of selection program. It's interesting in the fact that geneticists do genetics and nutritionists do nutrition and physiologists do, physiologists looking at mechanisms of that, but they don't typically come together. And that in this sort of program really needs to come together if you're going to develop a program that's actually going to work. Happily enough, our program worked rather well. We did a couple generations where we didn't see a lot of changes, which is not unsurprising, because what I've noticed in a lot of traits where there's been no selection pressure prior to that, it takes a couple generations for you to see separation of that trait, within the populations, especially between unselected, and selected. We were able to improve the ability of our fish to utilize plant-based. Specifically, we were looking at soybean meal, replacing that. Soybean meal has a lot of anti-nutritional factors. So sure, there's the protein component, which matches fish meal rather well, except for a few amino acids which have to be added. But if you have soybean meal too high, you get fish that develop gastroenteritis, basically the inflammation in the intestine, and they become sick. Then they quit eating, and they don't grow as well, and they become stressed and more likely to outbreak with disease. So at that time, when we started doing this, and again, there's been a lot of changes in diets, processing of soybean meal, incorporation, etc. But at that time, 12% was when they would see enteritis break out. And so we started our selection with using our stringency at 12%. While the other groups that were doing this, a lot of them had the idea, which, what we're going to do? We're going to hit them really hard, and then we're going to be able to take that top 1 or 2% and utilize that. The problem is, if you push any trait too hard, you're not selecting for what you think you're selecting for.
Yes.
And, basically there were real issues. Serendipitously, we chose that lower level. And, and then over generations, we increased it from 15 to 20 to 25 to 35% inclusion. And we showed, a number of different changes according to this. How they utilized it, how they transported amino acids, improvement across the intestinal membranes. We showed that there was a non-pathogen resistance improvement. So there was some effect on immunologically in the intestine. And for us, it proved favorable, because I know a lot of other traits where it's give and take.
Right.
But in general, we had mostly positive correlative effects that went with our selection program as we progressed it at that slow level in improving that. And that's where we're at in a nutshell. I mean, we've evaluated this because, again, we're interested in the mechanisms. And what I've always been fascinated is if you are selecting for something, what are you changing? I mean, you obviously
Yes.
have the trait you're interested in, but what else is changing? And is it good or bad? And how's it related mechanistically or physiologically to that trait you're looking at?
Mhm.
So, and that's what I've always found fascinating. So, again, we looked at a number of things. So, we did transcriptomics, proteomics, metabolomics. Um, we're doing some methylation related studies. We looked at, again, transport of amino acids, lipids, etc. We looked at disease challenges.
Mhm.
We looked at different stress. We looked at palatability effects, and just across the board to see what changes actually occurred and were they for the better or for the worse in the trade overall.
Right.
So that's it in a nutshell. I don't know if you want anything more.
It sounds like one of the logistical challenges was actually, getting this program started up and kind of deciding where to start in your selection intensity, and then using all of the tools that you already have at your facility to basically try to understand the genetic mechanisms of the traits that you care about and what may be coming along, as far as drag or just as part of the same pathway, but is in, affecting a different part of the phenotype or an entirely different phenotype.
Well, I mean, at the start, what was always so I was hard on for this, and I came in and basically you have to work with the infrastructure you have, and
Mhm.
that's always an issue. If you could design your own facility and start it up, that would be fantastic. Again, in hindsight, you would always change things. But
Yes.
when I first started out, the director here was going to give me a few tanks to do my genetics, and so we started that. And I went out and evaluated, and I introgressed 9 different strains of rainbow trout into this program because, again, there's probably more. There's greater differences within the between strains, but
Hmm.
some of those differences are going to be specific within strain,
Hmm.
even though it's not greater, but there's some specific for strain. So we introgressed that, and again, we started with taking about 20, 30 tanks, and as the success of the program, we showed that it was successful, and it progressed. We ended up taking over the majority of our wet lab for half the year, and the
Mm.
staff. I mean, we take over a lot of tanks now. It's not just a few, and we our own hatch house, our own raceways, and all the rest of that comes along with it. And we've tried to branch out into utilizing this and selecting for other things beyond the utilization of the plant protein, but the biosynthesis and conversion of plant lipids, and shown, that we've got publications that we can select for that, and it would be a good improvement. But again, you only have so much room that you can work with. Where you're going to establish,
Yes.
are you going to study it? Or as what we were doing, we were going beyond studying, but we were actually releasing germplasm to the industry. And so we can release germplasm where a lot of people they want production stocks. We're not
Right.
large enough to produce the numbers for production. We can release germplasm for people that have brood stock for them to incorporate that and utilize that then to grow out into production or expand it.
Excellent. Excellent. Okay, that's fantastic. Um, Looking at you, Josue, given what Ken's expressed about some of the needs and challenges, changing over time as well, can you explain your role as a BI coordinator and how you meet Ken's needs when he brings a question to you or a problem to you?
Of course. So I think a very important step is to listen to the needs of the program. Like Ken said, it's in hindsight, it will change everything and build everything again. But in my role as a coordinator, I have to listen to what he's looking for, what he has done, and also to the constraints as well. And my role basically would be to take his goals and his constraints in consideration, look for the assets that we have in BI, so experts in phenotyping, for example, experts in breeding, and bring those together and provide Ken with options for the solutions, keeping in mind the constraints, right? It's very easy to just say, hey, let's build a wet lab again and have these and those steps, right? We have to work around his program to fit the solutions to his flow and to his constraints.
Excellent.
So,
So go ahead, Ken.
I'm sorry, stepping back, I mean, after, Josue, and you were talking about issues that we had. Again, when we started, genotyping was very expensive. It was, sequencing was difficult, and even having panels for what you wanted. So originally, we maintained all our fish in our families in separate tanks, and and evaluated them accordingly. When we started genotyping, we had to rely on another group's, panels, gene panel that was here, and their pipeline flow and storage and whatever else. And that was a real constraint as we were progressing what we wanted to do. And then for another step, which again, BI has been invaluable, I'm not a quantitative geneticist. I've never claimed to be, even though that's, when you select a program, that's where they want to start. I did human and medical genetics in my background when I came into this. So with what BI has really brought to really help us, is to generate this pipeline that we have specifically for us, and a data storage, for the pedigree, for the selection, and for a quantitative, breeding selection that we can add into that. And then using that genotyping, where we can rear all the fish together. So we know we can take out these environmental effects that we might have been an issue, and remove that and improve our breeding program accordingly. BI brings a lot to the table to assist us, where we were basically at a dead end in trying to improve it in certain areas.